So, hello, I'm Jeanie Dean, and we're at the Milwaukee Theosophical Society.
Oh.
And trying to, oh, somebody else is coming in? Okay. Oh, all right. And come on in. Hey, good to see you, John. So, I'm so glad to be here, and I always like to give thanks to the scholars who went before us, because without them, we wouldn't be doing this. And it's a real testament to the nature of human, that humanness, that our knowledge transcends our individual lifespan, that we have this great database of knowledge that our ancestors pass on. So I honor that. So I'm trying to figure out on this screen how to get this thing moving here. All right. So, again, I'm Jeanie Dean, and we're at the Theosophical Society in Milwaukee. And this is part 2 of a series we've been doing on sacred geometry. To recap, we looked at general concepts of geometry in the first talk. We talked about the genesis of numbers and went through 3 dimensions. The first dimension, kind of like numerology, how one number generates another. Then we looked at how the second dimension, physical forms are generated, and then we looked at the paradox of zero, which kind of took us to another level, the third dimension, and we looked at plate forms, solid geometric forms. And we looked at the difference between circular forms as being feminine in nature, and then with this paradox of how 0 or 1, which came first? The egg, the egg or the chicken. And then we looked at how the vesica Pisces, which is this circular form that has 2 circles intersecting, is used as a primary foundation in the idea of generation of forms. And we didn't talk about it, but the vesica Pisces has been used for centuries for people like the Da Vinci and other artists and architects to generate other forms perfectly, because the drawing of the circle is irrefutable. You know, you take a point and then you have a string and you mark and you draw the line, and that makes a complete circle, and then we can intersect 2 circles with certain set point and create the vesica Pisces, and continuing we can overlap the radii of the circles and make other ones, and from there generate these other geometric forms. We can generate the triangle as the first object, and that's more of a practical application of geometry, and it's certainly a good thing. And we talked about how geometry and some of these ideas are really understood best through working with them in some sort of physical manner, even like drawing and using the compass and the square. But that vesica Pisces is a key to being able to make these figures, because then we can generate the other circular forms, and then by knowing the formulas, align a circle, align a square, and a pentagon, and so on onto the circles. Then we talked about the flower of life, the seed of life, Metatron, cube, and the Merkaba, which are very fundamental principles and things that have been introduced in the last few years to us. So we'll kind of begin then with, looking at refreshing our memory on the Metatron cube, and then we're going to look at the Platonic solids, the Fibonacci series. We're going to look at this idea of squaring the circle, time and measure, and the Great Pyramid, and then some overlap geometric forms and numbers, kind of like where we started it all out. And I hope we can get through it. This is a wonderful painting of the Metatron cube connected into a Merkaba by a scholar, Charles Gilchrist. I think I'm going to switch this up a little bit.
Yeah, I was wondering, because it's hard to see through you.
Oh,
and the computer.
So would you like it to be more to this way?
Well, let's see. If your stand was like
over this way?
Yeah, maybe if we move those chairs, and then your stand could be over.
Oh, okay.
Over the wall.
All right.
Oops, sorry. But I
Oh,
don't know
you
where
really
to
want to
put
go over
these.
there, huh?
Then we could see through.
Okay, otherwise we can also move this
But I
over.
want to put these in Mike's way.
Oh, that's fine.
Cookies.
Now I've moved that and destroyed that. So,
Yeah, that's good.
thank you,
You can
thank
see.
you. Okay.
Anyone want to look at these?
Oh, sure.
I hope I don't miss anything. All right.
Can you see Mark?
I can see Mike.
Mike, sorry. I can see, so I'm good.
Is Mike's head in the way? Okay, perfect. Okay, the flower of life, which is a format we're familiar with from Drum Below Melchizedek, and this figure that turns up in a lot of ancient images. So the flower of life can be understood. And I know we have a little pointer up here, stepping. I guess it's not here today. Okay. The package is in. Oh, well. So the flower of life is this combined, and this is really the Vesica Pisces also. And then the seed of life contains a flower of life, which is this intersection of 7 circles, 1 in the middle and then 6 around it. The fruit of life carries on this image, this component in its unified. And so this is 13 circles with a center point. And then we had this idea of the egg of life, which is in 3D, three-dimensional form. And the tree of life can be found in the flower of life. And also Metatron's cube, which is a very significant sacred geometry image, is implied in the fruit of life. And along with that, we also have the Merkaba. So this is all recap. So here again is the egg of life, which is the three-dimensional form of this seed of life with the seven circles inscribed together. And then this is kind of what we just saw, the flower of life, the seed of life, and the egg. Here's the seed of life and the flower of life with the tree, a very fundamental Kabbalah symbol, and kind of the last rendition of this. And by even looking at these things, it can, affect our energy and our kind of consciousness. But this is a nice rendition where it shows sort of the evolution. And again, that idea where we start out here, this is a circle, the Vesica Pisces, of 2 circles intersected. That idea of the fish body. And then from there, these additional circles are able to be generated using that simple compass idea and building into these perfect forms.
What's the difference between the fruit of life and the seed of life?
Well, the fruit of life is more of the idea of, the completion. So that's that one with the 13 circles. And it's inscribed in the flower of life, but you don't see the last point because this is the seed of life, this group, the 6 and the 1 in the center. And then the other 4 coming out on these quadrants are implied. Yeah. And I mean, they're a study in and of themselves and in the energetics of using them.
Are those all just intersecting circles of some
Right.
sort? Really?
And we talked about last time a little bit too how the line is a masculine polarity and the circle and curved line is a feminine, and that they both have a place in working with this science. So again, here's the difference. There's the fruit of life right there with the additional circles and another ring around the seed of life. Okay? And then here's this inscribing on the cube, the Metatron cube, and then we also have the star. And some of this goes back to the Book of Enoch, something that we had talked about in an earlier session. And so the Metatron cube is considered a very significant figure because it contains the 5 Platonic solids, which we'll talk about shortly. And it has the 13 circles connected at the edge. And it was described in the Book of Enoch, and there's an elaborate thing where Enoch goes on this journey, and these places are described, but they're really seen as inscribing that Metatron cube. And when Enoch is ascended, he becomes an angel, and he is given that name, Metatron. And he's one of the 3 biblical figures, Jesus, Enoch, and Ezekiel, who ascend and who was taken to the perfect Godhead. So again, then continuing, there's 13 intersecting center points. There's 2 tetrachs. The star of the Parcheesi board is also inscribed, and it's this pattern on the dollar bill that we use. So that's a whole other story. So the fruit of life is aligned to the Metatron cube, and this is some of the things that I've mentioned just in the previous. So the 13 sphere figure. And then there's the Merkaba, which is quite a bit referenced in Hebrew text, the old, what we call the Old Testament from a Christian point of view. But the word Merkaba is light, spirit, body. And it also represents the idea of a chariot. So this Merkaba is a moving vehicle, and sometimes it's associated with the Ark of the Covenant, that and the way that the angels overspread their wings and they touch from each side when you see images. And I should have put a picture in there, but that implies this connection of these fields of light that we are, and wheels within wheels. It's been compared to the DNA. So with this rendition, it's 3-dimensional, so it extends forward. And this is also, these 3 circles are inscribing the 20 degrees, the 0 degrees, and the 19 north and south of the equator, where the sacred sites, most of the sacred sites on the planet are. Like, yes, somebody's got a picture. Yes, of the Ark of the Covenant with angel wings.
That's awesome.
So the Hasidic teaching, also called the Hekalat, is the idea of 4 angels with 4 faces, 4 angels, 4 faces, 4 archetypes, and their wings intersect to actually move the Merkaba field forward, and these elements that they're representing are conjoined, and it's activated by 18 spherical breaths to the 7 heavens. And in order to sort of start the engine, you have to have the intention to serve God. And 5 winged wheels. So it's very profound, and we're just doing a sampler today, so but that's the general idea. This is a list of Merkaba texts from the 3rd and 9th century. The Yetzer Sephirah, we've maybe heard of that one. Some are less well known. And this is where we get the idea of this last sentence. God creates the universe combining 22 Hebrew letters with emanations of the numerals and the Sephirah. So it's very involved in some very profound Kabbalistic fundamental ideas. So again, this is another review looking at how the Vesica Pisces is used to derive and generate these other forms with being able to draw the perfect circle. Again, Platonic, the Metatron cube has the Platonic solids, 13 equal circles, 78 lines. It's got the double or stellated tetrahedron, the cube, and the octahedron all embedded in it. And then the dodecahedron and the icosahedron edges touch the star tetrahedron that fits the circle inside the outer cube. So this is considered also a 3D view, and there's 4-dimensional tesseract is another rendition of it. And these are some of these forms. You can see this is kind of finalizing what I was saying, how these forms are generated. So from these two, we can get the triangle first, then we can get the pentagon, and then we can get the pentagram. Here we can get the hexagon, and the 7 days of creation. And we can arrive at that mystical 7. Hello, Phoenix. Come on down. And we're looking at the seed of life, the tree of life. Hi, come on in. And the egg of life. And we'll finish up with that there. So you're just in time for the Platonic solids. So these are the 5 Platonic solids. And the tetrahedron, the octahedron, and the hedron means solid, and the prefix indicates how many faces it has. So the tetra has 4. This is an 8-sided figure. It's really 2 pyramids. And then the cube, which is called a hexahedron. The icosahedron, which has 12, returning to the use of the triangle, and then the dodecahedron, which means 20. So there's 20 faces. Pythagoras did a great deal of work on this, and Plato followed him. But there's quite a bit on the idea of 3, 4, and 5, and how these figures are 3-sided, 4-sided, and 5-sided, and the relationships. I'm just kind of putting that out there as a little teaser, if you will, because we won't spend much time on it, but that is a very kind of fundamental idea about this. And so we just looked at the flower of life, and now we can see how the Platonic solids intersect with these forms. So here's the star tetrahedron, which we saw as the Merkaba. And here's the square, the fruit of life. And then here's the octahedron, and the dodecahedron, and the icosahedron. So that is why that whole business of the Merkaba is so important, because it contains these solids. And there's a little problem with the dodecahedron, but it's resolved through a little correction. But overall, it's pretty profound how they all fit. And this is a representation of some antique rocks that have been found in Scotland, and they're kind of crude, but they represent these forms. And so they're more soft-edged stone figures that have somehow been carved or cut, representing each of these. So, and they're considered to be tens of thousands of years old, to pre-flood civilizations. And here's another picture of that. And then again, this is some of this from Pythagoras, the 3, the 4, the 5. And then each of these represents an element. So the tetrahedron is fire, the cube is earth, which totally makes sense. The octahedron, which is the 2 pyramids, is air. The icosahedron is water, and then the dodecahedron is what we consider to be ether or spirit matter.
Is that what Pythagoras said, or did somebody take what he said and, oh,
Well, everything from Pythagoras was that he wrote nothing. It was all like from his students, and but that's a very long established. That goes as far as we have written history on. I mean, some of this goes back to Euclid and Archimedes and Plato. And, they were early writing. So yes. So the Platonic solids have some unique qualities, that all the faces are the same size, all the angles are the same size, and they have the same number of vertices. So a tetrahedron is 4 triangles, and a cube is 6 square faces, and an octahedron is 8 equilateral triangles, and the dodecahedron is 12, and the icosahedron is 20 equilateral triangles. And some of that is represented in this chart. But there is this beauty in that they are these regular forms. And here it's summarized and color-coded with the faces, the points, and the edges. And then what becomes very significant is the degrees and the volume of these figures. So in this one, I'm creating quite a shadow. The core degree is 180 times 4, so that's 720. With the octahedron, it's 1440, the 12 times 12. And the hexahedron is a 90 degree times 6 faces, so that's 2160. And the icosahedron is 180 degrees times 20, so that's 3600. And then the dodecahedron is 540 degree total angles times 12. And these numbers, so that number 640, 6,480, I can tell you that one is the 1/4 of the cycle of the equinox, of the precession of the equinoxes, which is 25,900 something. So that's 1/4 of that. So all of these numbers have a very significant correlation with measures of time that we use and geometry. And that's the real, beauty, the awe, the splendor, the wonder of studying this, is seeing these patterns. And of course, they're all working with the same numbers. Why wouldn't they start to kind of show some patterns? So moving forward, we'll revisit those numbers again. And indeed, that could be just one focus of a talk, how I'm going to touch on it later. These are what the forms look like when they're flat, which is kind of fun. And last time we met, we took some of these and made them into shapes, and we can do that in our class. So you can fold them and see how they can be bent into form. Going on, the elements. So this is just pictures of the elements associated with them. Fire, air, earth, water, and ether. And so again, the Platonic solids encode 3, 4, 5 in the way the shapes fit. And that's represented in this little chart here. I'm wondering if that'll take away some of that shadow. Okay. So I thought this was cute. There was a poll of what people's favorite Platonic solid was, and I shamelessly scarfed it off the internet. But it turns out that they're kind of equally distributed, except for the square. At least the first 3. So the icosahedron and the dodecahedron are very popular, and then the tetrahedron and the octahedron follow.
The more complex. More popular.
Yeah, and there's Plato, and the medieval version of Da Vinci's Walking Man inscribed on the Pentagon. So that was, again, just a quick introduction, and we're going to look at the Fibonacci series. And I remember I had a teacher when I was just 19 or something, and he taught me this. And I'm still learning it, and it's still amazing. So this is a representation of the Fibonacci series as the blueprint for the formula for the spiral and growth. And this is an image of the belt of Orion. So that's, and here's an example of the Fibonacci, or the number phi with cubes, and each one of these has the same relation to the next one, to the next one, to the next one, in size and length. So it's been said that Leonardo of Pisa is Fibonacci, and he presumably introduced the Fibonacci sequence in 1202. It is also said that it was recognized in India for at least 1300 years. So here's what it is. So Fibonacci presented it to the West, and it's a sequence of numbers that have a relationship to each other, the same ratio from one to the next. So the first number is 1, and then you add that number to itself, and so that you have to start out with the 1 and the 1. So that's imperfect beginning, but then when you add 1 and 1, you get 2. Then you add 2 to the previous number 1, you get 3. And you add 3 to the previous number 2, you get 5, and 5 to 3 is 8. And 13 and 21, 34, 55, 89, and 144, and so on. I know that when I was pregnant, my partner, who was a rocket scientist, used that formula and figured out exactly how much weight the baby would be at a certain amount of time. And it was right according to the books, you know, what they said you should expect at 6 months and 7 months and 8 months. And it's this idea of somehow not doubling, but increasing by the ratio, which is 1.61, which I have indicated here, which is 1 2/3. So everything grows by a factor of what it is now added to it. So it's very interesting I like to put things into sort of homespun folk knowledge, but you can relate to that. So if you want to look at expanding something, you have to put in as much energy as there is now to make it become bigger, and it'll become 1.6% bigger. So each number sums the prior two, and then so this ratio of growth is evident in all of life. It's, you know, from the plants, as the leaves on a plant, the distance of the planets in our solar system, the ears of corn, the sunflower, and the ratio of our body parts, you know, the ratio of our fingers to our arm, and the ratio of our arm to our torso, and where the nose is compared to the top of the head. and the distance between the eyes. It just is a fundament. So it's very profound. So it's called the golden mean, the golden ratio, and it can be determined by dividing each term by the previous term. So that's how we get it. So 2 divided by 1, 3 divided by 2, 5 divided by 3, until we get to this point, average point up here. And there is no perfect, people have done arrays of what the number looks like when it's taken out to long decimal places, and there are some patterns that emerge. So this is an example of that. What happens, this image here is an excellent representation of the Fibonacci number. So we have a line that's a certain length. And that number 1.63 is here, so that's the relationship of these 2 points on that line. And music scales use this ratio as well. You know, like, a string has to be tuned, and the length of it is based on using this ratio. So the ratio of this line to that line is the same as this line to the full line. Does that make sense? So the ratio of the little number to the big line is the same ratio as the longer line to the total. And there's quite a, some people have said that, as earlier I started with acknowledging our ancestors, that this idea of this growth links each new generation to ancestors, preserving the continuity of knowledge and relationship. Phi can also be calculated as the square root of 5. So that would be this number here, this formula. And there's some other issues that come up with the square root of 2 in this, but I didn't want to include that. So this is a picture of many examples of spiral forms and using the phi. So each spiral has that relationship of the 2 parts to the whole, to the next layer. And it's pretty incredible. The square root of 3 relates to the Vesica Pisces, and it's indicated by a rectangle that encases the Vesica Pisces. And within that, and so this is again how we get the Vesica Pisces in a pure form of drawing 2 circles. So the Vesica Pisces is an extremely significant geometric tool. And so within it we can use the rectangle then, and then that gives the golden ratio. So this distance here is a ratio to the total length. And again, thanks to all our, people smarter than us, people smarter than me, figured this out and preserve this knowledge, and we can continue to use it and derive goodness from it. So the phi in the spiral is generated by a recursive idea of a golden triangle with that they have the relative side lengths of L, phi, and phi, like a chambered nautilus. And so here's an indication of that represented. And then what we also see is that the Fibonacci series in the spiral is echoing what's happening with the pentagon. And again, the Fibonacci number is the square root of 5. So here's a good representation of that. And the cube in the middle. And this is just sort of a little visual tour, but here we have sunflower and a fractal. I know that people studying the Schumann resonance, because the Schumann resonance of the Earth is somewhere around 7.8. And there's been studies showing that the Schumann resonance is changing. And it's such that airports have had to change some of their magnetic registers for people who are still flying with old style instruments and such. But that they postulated that given what we know about the Fibonacci series, when the Schumann resonance stabilizes, it'll probably go up to 13, which is the next number, given that this is a principle of growth. And that is a rule of this planet, this plane of existence. And it behooves us to be knowledgeable of it. So here again is the same idea. A and B, A is to B as A and B are together. And so these are again forms. This image with the cube, the rectangle, is so here's this rectangle, here's that rectangle, and then here's that rectangle. You see that? Okay, I'll point at it again. So we have a very small cube rectangle here. Then we've got this rectangle, and they each rotate. So this is to that, and then that rectangle is to this rectangle. And then this rectangle is to that rectangle. And we could, draw it out with a series of cubes, rectangles within the spiral. So even though it's a curved form, we can use the solid ideas of, the squared off rectangles to understand the mathematical formula there and the precision of it. So it's the formula of growth, this additive process. This is a beautiful rendition. I don't know if it's an actual, it kind of looks too perfect.
Is that a double helix?
Yeah, but when I saw it, some of the reference seemed to imply it was actually an actual photo, but it's the internet. So these are some more images of phi in nature, the Fibonacci series. So that number 1.681 is called phi for Fibonacci. And so this is on a feather. This is a mushroom. And so again, there's the cube, the rectangle with the spiral. And each one inscribes, so there's the first one, the second one, the third one. So here's some examples of this ratio in the human body. So the torso is in proportion to the total length. And the head to the thighs is one ratio. Here's how the arms are in relation to the total length. The face and portions of the hand. And this is the whole body inscribed on a spiral. And within the solar system, here's the planets, and they pretty much conform to this factor. I mean, there's some, variation where it's not machine tool perfect. In between Mars and Jupiter, there's a big distance, and that's where the meteor shower is, because there was a planet there. Jupiter is 12 years, and Saturn is 28. Those are sort of key numbers. Like when you look at Chinese astrology, and it's 1 year, the year of the rabbit and the dog and the horse, that's the Jupiter alignment, really. And everyone born in 1 year shares a Jupiter influence together. Saturn is considered the kind of the marker of human life, and if you divide that by 4, you get the age of reason. 7 times 4 is 28. 1/4 of 28 is 7. And the age of puberty, 14. And the age of reason, 21. And adulthood, 28. And 3 of those Saturn cycles, 3 times 28 equals a Uranus cycle, which is 84. And Neptune is a little off, but Pluto and Pluto and Uranus have a strong relationship as well. So we are living in an ordered world. And it's helpful to know something about how it works. I mean, this is like the instruction manual. And so here's examples of using Fibonacci numbers in time. And another picture of the galaxy, the same formula. This is repeating some of these numbers having to do with the cycles of the planets. And now it's ensconced in my PowerPoint for us all to look at in depth another time. So the Earth, Moon, and Phi, and this is a very profound piece of information. We all know, isn't it amazing how the Moon and the Sun are equidistant, or our distance is such that the Moon can create an eclipse with the Sun and fit right over it. So it involves Phi as a factor. There's this idea of squaring the circle, and that's like one of those geological Mount Everest formulas that people have worked on throughout the ages. And in this example, the square is not inside the radius of the circle, but extends out of it. And this is said to be a relationship that the Great Pyramid has to the size of the Earth. But the factor then that involves is what the size of the Moon is. So here's another image of Phi and the number add into infinity. So the number Phi turns up in the Great Pyramid if we draw a Pythagorean triangle. Then we can see the number Phi on that point, that line, and then the square root of Phi. So this would be one part of the parameter. This is Phi being divided into different numbers. So here's the 16.183803, and then it's reversed in the square root of 1. There's some sort of pattern here indicated by the color, and it's one of those things that's a real conundrum. It's fascinating if you have the time for it. Here's another example of growth with the Fibonacci number. So here's a plant, and then here's the addition. Here's where it was, where the length of the degree was 137, and then it was growing, and that's the next line, the next distance. And this is a picture of a DNA polymer showing these Fibonacci relationships also. And just a close-up of a sunflower. Here's circles hand-drawn indicating the radiuses, how they fit together. Just kind of an easy thing to see. This is more for the real math whiz-bangs. This is about working with phi in both the square root and squaring it. So it's squared, it equals 2.168, and there's a relationship between phi equals 1 plus 1 divided by 1 plus 1. I mean, this is the stuff of deep philosophy. This is where math and philosophy meet. And, you know, where a little mushroom might help. And again, we don't have time, but just to bring that to your awareness, how profound it is as a number. So there's a little relationship between phi and the seed of light, which we looked at earlier. And I guess I wanted to go back to this image down on the bottom here. So that's showing that factor. And the seed of life is also there in what we recognize as a sunflower pattern. So the Platonic solids related to time and measure is an interesting thing. And here's some five-pointed, this is a five-pointed figure, a jasmine, the moon, and a series of fractals making a ship. So two pyramids join into an 8-sided octahedron, and the picture that goes with it is way down at the end. I forgot to move that. So when we measure time, some obvious key numbers come up. So we have a 24-hour day. That equals 1,400 minutes. We have 86,400 seconds. And half of that would be 43,200. A foot is 12 inches. A square foot is 144. A cubic foot is 1728, a yard is 36, a square yard is 1296, and a cubic yard is 27 cubic feet. The circumference of a circle is 363 degrees, and it has 21,600 minutes. That's that number, 60 times 360. And then within that, we've got 1 million seconds within a 360-degree circle. So these are some very common numbers that come up again and again in looking at time measure and the form and the volume of the Platonic solids. So also what's very significant is all of these numbers have what's called a sum digit. And a sum digit is where you add up the numbers of a number and see what they equal. And the sum digits in all of these are 9. So this is 9, this is 18, and that's 9, and 4 and 3 and 2 is 9, and 4 and 3, 432. And we can also look at these numbers in scale. So we can look at 432 or 4,320 or 4.32. They all have the same sort of representation or vibration quality. So when we start looking at some of these numbers, 864 is the sun's diameter, and it's also the number of seconds in a day, which we just saw. And it's the height of the Washington Monument, which relates to using these numbers to send messages. The use of the meter comes with a lot of the use of the number 400. And the moon is 400 times closer to the Earth, and the moon is 400 times smaller than the sun. The Earth turns 400 times faster than the moon, and the circumference of the Earth is 40 million meters, which would use that scale of that number. The meter is said to be the distance traveled by light in a vacuum, which is this 299 times 7, 92, 458. And so that number also will come up. Within Plato's work, so the Earth is said to be 3,960 miles in diameter, and the octahedron is 1440 degrees, and the icosahedron is 3600 degrees. And putting these together, they equal 5040. And so that's the sum of the Earth and the Moon in miles. And the total angles of the octahedron and the icosahedron is 540 degrees also. So these numbers come together. That's one example of that pairing. Continuing looking at time units. So this is a little repeat. So 24, 1400, 86,000, 4,300, 200, like 43, 2, that's all I'm going to say. And the great recessional cycle, or the precession of the equinoxes, is based on a number of years, 25,920 years. And so 72 years of these is equal to a 360-day year. And that is considered to be 1 minute of movement, so of the precession. So in 72 years it moves 1 minute, and that's considered a good average for the lifespan of a human being. So there's a relationship, a ratio right there. Some other numbers that come into play is we divide the precession of the equinoxes into 12 ages using the zodiac, and each of those is 2160 years. And right now we're at the transition into the Aquarian age from Pisces, and with a 200-year cusp, I would add, that began about 120 years ago already. So we got a few more years to go, but not. We're mostly there. With 4/4 of that is 6,480, which we saw was a number in the volume of one of the solids. And here's the number of seconds and the number of minutes. In the recessional year, 108 minutes, and we have 1,080 days. The Mayan year also uses some of these numbers, which is based on 144,000 days in a 20 Piton Bacton, 7,200 days, which is half of the Bacton. A 360-day period is for 1 year. called a ton, and a kin is 20 days, which would be kind of like one of our months. Again, to go into this in great depth would be a program on its own. But if we just look at some simple numbers then, with the planet, the solar radius is 42,200 miles. The solar diameter is 864,400 miles. And these numbers come up in time measure. The moon has a radius of 1,080 miles, and we just saw that 1080 comes up, or 108 comes up. 108 is often considered the number associated with the moon. Here are some numbers for the Earth's diameter and the Earth's radius. And this is a nice representation of some of those. So again, these are the volume of these solids, and when we add them together, they equal the circumference of the Earth. There are other patterns as well. The idea of squaring the circle is something that, along with Metatron's cube, which contains all these solids, is a inquiry that sacred geometry pursues. And there's different solutions and formulas. And squaring the circle often refers to this relationship between the sun and the moon, and how using the sun and the moon helps us figure out what the size of the planet is, how fast it's moving, what's a unit of time. And so it's a square with an area of 4 has a width of 2, and a circle with an area of 4 has a width of 2.25. So this is a relationship called 9 to 8, or 1.125, and this number is multiplied and then divided, it equals the 1.2. And when we cross-reference these, there's a 99.7 degree of accuracy. This ratio 9 to 8 also occurs in music theory. So this is what we just saw represented in this graphic with the Earth and the moon size comparison. Well, it looks like I have the word Earth twice here. And so the Earth's radius equals the square of the circle with equal parameters. And so this is another method. So squaring with the parameter 4 is a width of 1. A circle with a circumference has a width of 1.2. And the moon, and so this number 1.27396 is close to the moon's monthly rotation of 27.321 days, and that's 99%. There is a factor of 14 to 11, which is 1.272727, and then divided that by 1 equals this number, which we just saw up here, the relationship of the square and the circle. And again, this is kind of, you know, heavy calculating for, I just got a lecture, but the formula's there. In either one of these systems, one uses the 4 to 1 and the other uses the 2 to 1. One is 9 to 8 and the other is 14 to 11. It comes out with a factor for the differences between those, and correlates with things that are inscribed in the Great Pyramid as well. The number 2732, which we just saw as being a factor of this formula, 2732, is very significant, and it's considered the ratio of the Earth's diameter, the moon's diameter. It's a square perimeter to a circle that has the same diameter. A circle inside a square has, well, I'm not going to go into the formula, but it also is a factor in the Great Pyramid's height to half its base, and thus the Great Pyramid squares the circle. Negative 273.2 is the temperature of absolute zero, and absolute zero is 273.2% colder than the temperature it takes to boil. 273 days is the actual average length of pregnancy, which is 10 sidereal months, and 27.3 days is the human menstrual cycle. 27.32 Earth days is the period of the moon for one complete rotation, and 1/273.2 is the theory of how gases expand per 1 degree. So there's quite a few things contained within that value, and it goes back to the volume of one of the spheres. There's more with relating it to the sun specifically. So it's considered the cosmic background radiation. Sunspots are also 27.3 days. But when I've talked with Mayan elders, they say it's 22 days. So there's a little, disagreement perhaps. Water changes phase at 273 Kelvin. There's 273 days from summer solstice to vernal equinox. This number is the circumference of the sun in miles, 2.73 million. I think it's 270. Okay, triple point of water is defined at that number. And the Earth and Moon orbital periods are reciprocal of that number. So then we get 366 days in a sidereal year. 273 is, in the formula, is the acceleration of the sun. And the square and circle in 3D, the cube and the sphere, are key concepts in the teachings of Walter Russell, whom Walter Cronkite declared to be the Leonardo da Vinci of our time. So write that down, Walter Russell, and his work on the cube and the sphere. And how are we doing? So here we are, spinning top of dynamic movement, balancing on a point. And maybe it's time to finish up. So geodesy is the measure of the Earth, and this is some of the history of that. And there's this whole controversy over, is it, what's a foot, what's a cubit foot, what's a pace, what's a mile. But that one author I mentioned, Michel, and his book, Measuring the Earth, provides excellent detail on what the cubic foot is and how it's part of the measure of the Great Pyramid. He also points out that the same information is available at Stonehenge and the Parthenon, and there are variations between the Greek foot, the Roman foot, the Hebrew foot, the Egyptian foot, and the English foot. It's by degrees of decimal places. However, he also found that with many of these sites, that based on their longitude and latitude, they'll have a different representation of what the foot is, because they're representing that different length. Because the latitude at a northern place is different than it is at a southern location, because of the circle becoming smaller. And so the latitude is the widest circle at the equator and the smallest at the pole. And the pyramid contains a model of the Earth using the number 1, the ratio 1/432, which we just saw as being encoding a lot with the sun. And one of the things that happens is that there's two formulas for what is the perimeter of the Great Pyramid. So you see this? This is a representation of the Great Pyramid. And it's paradoxical. Do you take the perimeter of the Great Pyramid with the casings on it, or do you take the perimeter with the casings off? Well, it turns out that both numbers are relevant, and they represent the fact that the Earth itself has a different radius at the equator. There's a bulge in the Earth, and this bulge in the Earth actually helps it rotate. It's a factor in its spinning, so it's not a perfect globe. So there's this variation in what the diameter is, and the pyramid represents that with these two different numbers. And that's kind of stuff that John Michel and some of his teachers brought forth. But then here again, this is by the wonderful artist Scott Onsta, representing how the pyramid is squaring the Earth, and instead of the circle here, he's using a second pyramid form to show this distance. And that distance covers this anomaly between the Earth and the Moon. And there's this paradox, even though there's all these numbers with these very precise forms and ratios, there's paradoxical aspects to it. Just like 0 and 1 are paradoxical. Is 0 nothing, or is it a something because it is a something? Is 0 1 because it is a thing? And so even within getting at this idea of putting a square in a circle, the formula isn't perfect, and then there's this paradoxical other factor that has to be accounted for. And then these incredible structures contain those numbers showing it. And this is Stonehenge, by the way, this figure here. And when I studied up on the Great Pyramid in Stonehenge, when I was just 19 or something in college, I noticed, it said that in the Grand Gallery there's a row of 27 holes along the Grand Gallery. Nobody really knows what they're for. They're little square holes, and they think that something was put in them, marker or some side. And that within, there's the inner circle and the outer circle, the same thing. There's 54 holes around the inner circle of Stonehenge, and they think they may have been putting, holes in them for whatever they were measuring that week or day or something. But that number 54 is a common between them. It's just one minor thing of this great knowledge that is being presented through these two sites and others. Here's some of the history and the detail about the Great Pyramid. It's 480 feet high. It's 756 at the base. And it was John Charles Webb who said that the latitude of the Grand Gallery at Giza equals this number, and it matches up with Google Earth and the speed of light. The pyramid is based on a degree of 51.51 degrees, which is also paradoxical, but we don't have time to go into all of that. But it's also close to the degree of a pentagon, and it uses this factor 7 to 11. And a half triangle encodes 365 days by 20 lunations, and it gives the moon cycle. So those numbers are kind of baroque, 365 days, but that's an accurate number for our actual year, and it has the 20 lunations represented through this 5150 degree. So there's more than we could just do the Great Pyramid and all the numbers and pi and phi are also represented in the Great Pyramid. Here's some examples of some of those numbers. So here's the one base, and here's the length. Here's 411. And then this is feet, 706 feet. Here's the angle. And there's a factor of 4/3 here. And there's 432. I'm not going to go into the details on this, but it's showing the golden ratio through the height and the width. And all of this chart breaks down how the two values for the pyramid base show the model of the Earth's hemisphere as 1/432, a scale for the planet Earth. So 1/432 is the scale for the planet Earth. We should have put the air on.
One way, no.
Yeah. So there's a piece here on the standard measure and the different distances for the mile. Again, it's probably a lot to look at. Here's the last piece I have is just some things on some key numbers that we recognize. 360 is a prime number, and it's 2 to the third plus 3 to the second times 5. 360 squared is 1296, a number that comes up in the precession of the equinoxes. 360 cubed is a factor for the Great Pyramid. The square root of 360 is 18.97, and the cube root is 7.11. It has 24 divisors, and these are all of them. So when people ask about why do we use 360-degree circles, it's an extremely powerful number. And that gives us our 360 seconds is equal to 6 minutes. And it takes about 3 minutes to count to 360. 60 and 9 are also very important numbers related to time measure. We inherited that from the Babylonians. 12 hours equals 43,200 seconds. There's that 432 again. And 432 hertz is a highly significant frequency, and these numbers also relate to the use of 9. And here's some factors with the division of the day into minutes and hours of 60. And 3, 6, and 9 are considered very significant. So this is going back to what we looked at with the Pythagorean solids. In this list here, these are the sums of the degrees. So 180, 360, 540, by 81 equals 1, 2, 3, 4, 5, 6, 7, 8. 8 into 81 is 987, 6, 5, 4, 3, 2. That number times 9 equals 888. That number times 2, 3, 4, 5, 6, 7, 8, 9 times 9 equals 111. So 9 has this capacity to yield itself or yield the thing that it was combined with. It's you know, and it's right there in these quirky little additions and multiplications. 432 times 432 equals 186,624, and that's the accepted constant for the speed of light. And I mean, some of this you could consider almost academic, but 12 times 360 is 4320, that number that we saw earlier. And the numbers 9 arranged in a group of 3 add up to 15. So it's a common magic square. And Tesla was obsessive about 369, and 9 comes up in the formula for the Rodin coil, and I didn't even spend any time showing it, but it's a very interesting new mathematical geometric concept that people have only been working with for this century, or the 20th century was only, and it kind of looks like the thing but an idea that 9 is a point at which nature begins and ends. And Tesla said if you only knew the magnificence of 369, you'd have the key to the universe. Tesla was said to walk around a building 3 times before he would enter the door. He was that obsessive about 369. And this is just the idea of a mechanical object to measure the universe. And here's a representation of the number of man through these Platonic solids added together by their volume and divided by the cube. And then there's the 2160 miles for the circumference of the equator. I always thought 666 was the population, the number of man. And of course the world population was 6.66 billion about 10 years ago. We've already gone up to 7.76 billion now. So that's kind of rapid growth we're in. There are so many representations of 666. So that's the completion. I thought I had a summary here, but we probably are quite complete. Thoughts, questions, ideas? So who's interested in, well, actually I'm going to just wait a moment.
Well, it is so complex.
It's a lot of information.
Yeah.
It's nice to know that there's some order to the universe, I think.
Mm-hmm. What did you find most useful?
I find the golden ratio is useful in various mathematical situations in programming.
Yeah. I think so too, and the array of its application is...
It just turns out that when you solve certain equations, it's the right ratio to take.
Mm-hmm.
And so all these programs have 1.618
Mm-hmm.
in their little embedding.
And that makes me think the pyramid, 1.1/432. That's the ratio for the Great Pyramid to the Earth. 432,000, though. 432.
You said that the tetrahedron represents fire.
Uh-huh.
Well, actually the tetrahedron is, what can I say, that's kind of like a symbol for life, because life is based on the carbon atom, and the carbon atom is tetrahedral in shape.
And formed by fire.
Mm-hmm. Right. There's some cross-referencing of the periodic table as well, and you're just opening that door.
Yeah, it's the same thing with some of the shapes of the atoms. Carbon is tetrahedral. I mean, if you take a look at the shapes of other atoms, they would be, I can't remember from general chemistry, there's, what's the second one there?
The cube or the octahedron?
Yeah, the octahedron has to do with the orbitals.
Mm-hmm. Like
The shape of the
like a gyroscope or a top. And 108 the number for the moon is the atomic weight of silver. And if I had more time, I would have looked at more of these cross-references. So, what other thoughts or observations?
I'm just wondering, is there any ratios or anything that would show pi 3.1416 or a natural log of E, which is I think like 2.71 something?
There is, and I wasn't able to pursue that inquiry, but there is something about that, and it.
Like phi is 1, which is
Mm-hmm.
1.61 something, and E is another number that just goes on and on and on.
Right. Yeah, and even that is mystical and significant in its own right.
It's also mathematical.
It is mathematical.
And there, where it shows the circumference to the diameter is a pi, and then there's hyperbolic sine and cosines, and those are based on E.
Yes, and I
then
can imagine.
also sine and cosine itself is based on E. You have the sum of two exponentials.
Right. Well, yeah, that's what
It's just from their definitions,
Yeah, right.
what the number over the factorial and the number. So, study a lot of that in engineering.
and part of that idea is how does it play out in life? What does it mean in my life? And even just building. I know, looking at the Merkaba, I started to have some insights just within even the metaphorical language about it being described as these angel wings moving this engine, and so I know a lot of people are drawn to that symbol, and for good reason. It contains a lot and is something to contemplate. It is a matter of philosophic inquiry or spiritual inquiry, no matter how you draw it.
Oh, did you come across anything, because in the beginning you were saying some of the ancient people would generate a circle with some string and a stick, and then it came to the compass. Did you, is it possible with a compass to create a lot of these?
Right. And that came later. And some of the forms can definitely be generated. And I think one of the things we're going to do in the classes, we're going to do some drawing like that. And again, it's just like going back to primary school, but to work with the forms is, by drawing them is a fundamental thing to do. And it's a good way to experience it. And there's a wealth of videos too on YouTube showing you how to do that, how to draw with just the circle, just using the Vesica Pisces and a compass, or the triangle. So any other thoughts, questions? Okay, well.